Today we're going to go over doing some image translation using GDAL with some different compressions, removing bands, building some overviews to get an idea, one, for some of the tools available to do it with, and number two, to better understand what these different things mean. So to get started, the first thing you'll have to do is get yourself a copy of GDAL. If you're using Windows, the easiest way is to install the OS Geo4W. You can go here to their website and download it. And once that's installed, you should keep the defaults, makes everything a little easier. Once you get that installed, then we can move over. We'll start looking at some example data. So what we've got here is we have some 4-band images. Just image tiles that are 4 bands. That means they've got a red band, a blue band, a green band, and they have a fourth, which in most cases, and in this case, is an infrared or near infrared band. You see it's just cropland, woods. I included this, you can see this white space. This is a redacted area. And that's going to show us what some of the different options on image translation can do when you use different compressions and remove and add bands. And it'll help us visualize those differences. So to get started, we're going to do all this with some batch files. It's the easiest way, kind of a quick way to go from a directory full of images that you want to do something to another directory full of images that you have transformed in some way. So we'll start off with removing the 4th band. So once you've got your OS Geo4W install done, we can use those tools from a batch file. So let's get started. We'll do, so this is remove band bat. So to keep my screen from getting too cluttered, usually I like to go ahead and set echo off. So every command that's run doesn't print on the screen, only things that you want to print to the screen print, which you can do with an echo. So since you got that installed, the OS Geo4W installed, it comes with this nice little utility batch file to set the environment. And that sets all your paths so that you don't have to do that manually. It sets the paths to the executables and to the auxiliary files and the data for projections and all those kind of things. So the next thing we're going to want to do is we've got our input directory here. See, has our 4-band images. We're going to use that, and we're going to set a variable in our batch file for that input directory, and then we're going to need an output directory. We'll see that. We're going to go here to this 3-band, and we'll go ahead and put a variable in for that. Now what we can do is we can loop through all the images in this directory. So we'll do a 4, we'll double up our % in a file. That's when you're doing it from the command prompt, you just need 1, but in a bat file you'll need 2. And so we'll do for every item in our input directory, but only those files that end in TIFF. We're going to do something. What we're going to do is we're going to do a GDAL translate. And the GDAL translate utility will do band manipulation, it'll do projections. You can go from one projection to another. You can compress images with several different compression algorithms. It's a really useful tool, especially if you need to do a whole lot of this at once. So now that we've got this, what we're going to do is we're going to tell GDAL translate that we're going to operate on bands band 1, minus B band 2, minus B band 3. And that B1, B2, and B3, that corresponds to your red, green, and blue bands. So we're going to drop out our infrared band. And then we're going to add some options. So we're going to say CO, which is a creation option, and we're going to say tiled equals yes. What this does is it writes out the TIFF instead of stripes, where the data is read as one pixel all the way across the image. Instead, it's written in chunks. So 256 pixels across and 256 pixels down, which makes it read a little quicker in our GIS software, especially for display. So now we've got our options set. We're going to use bands 1, 2, and 3. We're going to tile our output. And now we're going to tell it where to come from, which would be %%I. And that will be a single image from our input directory. Now we got to tell it where to go. And that will be %out directory / %% tilde indexi. And what that says is this item from our directory, but the tilde in X says just the file name and the extension, please. So we're reading from one directory, writing out to a different one. And to make it show up nice and pretty, we're going to use another GDAL utility, which is GDAL ADDO, which is add overviews. And we're going to add an option RO, which means read only. So we'll be writing our overviews to a separate file instead of adding them in as internal overviews. Some of you may know these as pyramids. We have another option R, which is our resampling algorithm. There's a ton to choose from. It defaults to average, which for aerial photos does a pretty good job. It looks good. So we're going to build our overview on our output file. So we'll say out here / once again %% tilde indexi. So that's our out directory and our input file, but only the name and extension. And then we'll tell it how many levels to do. So we tell it what size we want. So we want it 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. So that's starts off at half the number of pixels, a quarter, eighth, 16th, all the way down. So what we'll do is we'll save this file, and what we'll do is we'll run it. So from our command line here, I've got a terminal open in Visual Studio Code, which is my text editor of choice these days. So we're going to do that, and all we have to do is run it. what you'll see happening is it's outputting progress, and what we've got are images that have the fourth band removed. So we'll have a look here. See, this is our original right there. And here's the same one, but with 3 bands. What you might notice right off the bat is that my phone's ringing. But you might also notice that they look the same. What we're looking at, or we're just looking at the 3 bands right now. So if we go, we can actually turn on this 4th band only. And we'll set it as our red band. What you can see is this 4th band is there in this one, and there's only 3 bands in our output. And you say, oh yeah, you can always just ignore the band, but you'll notice for one of these images, our 3-band image is about 300 meg and our 4-band image is about 400 meg. So we've reduced our file size dramatically by removing a band that we may or may not have needed. The inverse of this would be if you just wanted to have the 4th band to use. We can come back and we can switch. Switch, instead of doing bands 1, 2, and 3, we can just say we want to use band 4. So it's only going to read 1 band, which would be that band, and we're going to put those in a different output directory, which would be our example 1-band images. Let's save this, and we can run it. There it goes. And what you'll see here is now our file sizes have dropped down to 100 meg apiece. In case you haven't caught on yet, each band is about 100 meg. What you'll see here is we just got a single band, so no color, it's monochrome. This is infrared, so you can use it to symbolize your vegetative cover, which is nice. I'll just set on. And the greener it is, the more vegetation, or it's a little easier to display that way. So removing bands is not the only thing we can do. We can also do some compression. And so one of the things you might need to do is save a little space on some images that you have. And what you might want to do is do JPEG compression. Now, JPEG compression is a lossy compression, which means you actually lose a little bit of data when you do the compression. For the most part, it's going to be hard to tell, but when you get in, zoom in close, often you'll be able to see a few small artifacts here and there where the compression kind of blurs your data just a little bit. So what we've done, we've gone back in and we've switched back to using bands 1, 2, and 3. We are still going to say it's tiled, and now we're going to do a CO creation option compress equals JPEG. Now we can go a little farther with this compression, and we can do CO, which is creation option photometric equals YCBCR. And that is a separate color space with, so it's not RGB, it's YCBCR, which I can't remember all the letters are right this minute. But that is an indexed color system, so it makes your file even smaller without having to store each value in every pixel. It stores an index. We'll change our output directory again, and we'll do this one as compress JPEG. And here's where you have another option. So on your overviews, to save a little space, you can compress your overviews as well. So what we can do here is we can add in some of our options for compressing overviews. And the switch is a little different now. It's -- config, and then we'll say compress overview is JPEG, photometric overview YCBCR, and then we're going to interleave pixel. All right, so we'll save that one, and we'll run it. There we go. So if you'll remember, our 3-band image came out to about 300 meg apiece with no compression. Our JPEG compressed images are going to come out much smaller. So that same image that was 300 meg before is now about 12. And as we'll see, let's go back to our 40-band. We'll add this one in. You can see that's what it looks like. And let's add the same one from our compressed. So what you might notice right off the bat is over here in this area, everything looks remarkably the same. I can see this is off, this is on. Out here, everything is basically the same. Maybe a little tough to see on the video, but when you toggle back and forth, you can see some small artifacts scattered around. Like I said, for most things, it'll be very, very hard to notice. But what you will notice is out here on the edge. So when we do our JPEG compression, because we're removing some of that data, you'll get this kind of ragged edge where these pixels were 100% black, which, the value for the R, G, and B bands was all set to 0. But when we do our JPEG compression, we lose a little bit of that data, and right here on the edge, these are just very close to black and not all the way, and so they show up as this kind of ragged edge. On completely square tiles, it wouldn't make a difference because every ounce of the image is filled with data. These images, we have some no data values, and this is what happens on the edge. But it is nice to save all that space. If we don't want to lose any data, if we want to keep our data as best we can and still do some compression, we have a few options. So we can compress LZW and deflate. We'll do deflate right now. LZW, you would just set your compression to LZW, and that's it. Deflate has the option to add a predictor. Which reads the images around it the cells around the cell it's trying to compress to better implement the algorithm. I got a little out of my depth there. Some of these things I don't quite grasp how the math works, but I do understand how the compression works. All right, so what we'll do is we're going to remove our compression on our overview. We'll keep our compression on for our image, and we'll set this to compress the deflate. Save it, and we can run it. And what you'll see here in just a second when we get a little bit done. So the deflate algorithm takes a minute. When you're not doing any compression, it's extremely quick. But when you are compressing an image, especially with a lossless compression, your computer has to do a little work to try and cram the data into a smaller space but not lose anything. And that's understandable. But if we'll look here with our first image, you can see for all 3 bands now we're down to 100 megs. So we've shaved off almost 200 megabytes off that image by compressing it. And let's add that one in so we can see the difference. I think we're quite done yet with our, nope, we're gonna wait just a second. Almost done. Come back to our map here. Let's see. So now, same image again. And we've got at the top here is our deflate compression, which is much smaller, but see no loss in quality. The compressed image and the uncompressed image look exactly the same. And we'll compare that to what our JPEG compressed image looks like. Let's see. Along the edge, there's that visible boundary you can see, but out here, there's no noticeable difference. There's a quick overview of a few things you can do with GDAL to do some image manipulation. There are a ton of utilities for GDAL, including warp, to GDAL warp, where you can change coordinate values, burn, where you can create a new image with graphics burned in or drawn onto the pixel surface, which is useful if you need to have a single image with some map data on it. And GDAL info, which is a utility to give you information about almost any kind of geospatial format, images, vector data. It's all very useful. And you can read about all these nice utilities at their website. Each tool's got a nice little blurb here about all the different options, and then each option is explained as to what it does. Hopefully I'll get a chance to come back very soon and do another video where we do some coordinate transformation, where we take images in one coordinate system and transform them to another. All right, we'll see you all very soon.